The collapse of the Atlantic Ocean current, would ripple across the world, according to a study. And I've also copied the real-time currents of the water currents around the world for you to watch as well. And I'll leave a link below on Null School for you to see that. You can also check the atmosphere temperatures, water temperatures, air temperatures, and pollution. Now, climate change is slowing down the conveyor belt of ocean currents that brings warm water from the tropics up to the northern Atlantic. Our research published today, June 6th, they say, in Nature, Climate Change looks at the profound consequences of global climate of this Atlantic conveyor collapses entirely. This is from the conversation, but published June 13th, so just 3 days ago. So the Atlantic conveyor collapses entirely, they said. We found the collapse of the system called the Atlantic Meridional Overturning Circulation would shift the Earth's climate to a more La Nina-like state. This would mean more flooding rains over eastern Australia and worse droughts and bushfire seasons over southwest United States. East Coast Australians know what unrelenting La Nina feels like. Climate change has loaded our atmosphere with moister air, while 2 summers of La Nina warmed the ocean north of Australia. Both contributed to some of the wettest conditions ever experienced, with record-breaking floods in New South Wales and Queensland. Meanwhile, over the southwest of North America, a record drought and severe bushfires have put a huge strain on the emergency services and agriculture, with the 2021 fires alone estimated to have cost at least $70 billion. Earth's climate is dynamic, variable, and ever-changing, but our current trajectory of unabated greenhouse gas emissions is giving the whole system a giant kick that'll have uncertain consequences that will rewrite our textbook description of the planet's ocean circulation and its impact. What is the Atlantic Overturning Meridional Circulation? The Atlantic Overturning Circulation comprises a massive flow of warm tropical water to the North Atlantic that helps keep European climate mild, while allowing the tropics a chance to lose excess heat. An equivalent overturning of Antarctic waters can be found in the Southern Hemisphere. Climate records reaching back 120,000 years reveal the Atlantic overturning circulation has switched off or dramatically slowed during ice ages. It switches on and placates European climate during so-called interglacial periods when the Earth's climate is warmer. Since human civilization began around 5,000 years ago, the Atlantic overturning has been relatively stable, but over the past few decades, a slowdown has been detected, and this has scientists worried. Why the slowdown? One ambiguous consequence of global warming is the melting of polar ice caps in Greenland and Antarctica. When these ice caps melt, they dump massive amounts of fresh water into the oceans, making water more buoyant and reducing the sinking of dense water at high altitudes. Around Greenland alone, a massive 5 trillion tons of ice has melted in the past 20 years. That's equivalent of 10,000 Sydney harbors worth of fresh water. This melt rate is set to increase over the coming decades if global warming continues unabated. A collapse of the North Atlantic and Antarctic overturning circulations would profoundly alter the anatomy of the world's oceans. It would make them fresher at depth, deplete them of oxygen, and starve the upper ocean of the upwelling of nutrients provided when deep waters resurface from the ocean abyss. The implications for marine ecosystems would be profound. With Greenland ice melt already well underway, scientists estimate the Atlantic overturning is at its weakest for at least the last millennium, that's the past 1,000 years, with predictions of a future collapse on the cards in coming centuries if greenhouse gas emissions go unchecked. The ramifications of a slowdown. In our study, we used a comprehensive global model to examine what Earth's climate would look like under such a collapse. We switched the Atlantic overturning off by applying a massive meltwater anomaly to the North Atlantic, and when compared this to an equivalent run with no meltwater applied. Our focus was to look beyond the well-known regional impacts around Europe and North America, and to check how Earth's climate would change in remote locations as far south as Antarctica. The first thing the model simulations revealed was that without the Atlantic overturning, a massive pileup of heat builds up just south of the equator. This excess of tropical Atlantic heat pushes more warm, moist water into the upper atmosphere, around 10 kilometers into the atmosphere, causing dry air to descend over the Pacific. The descending air then strengthens trade winds, which pushes warm water towards the Indonesian seas, and this helps put the tropical Pacific into a La Nina-like state. Australians may think of La Nina summers as cool and wet, but under the long-term warming trend of climate change, their worst impacts would be flooding rain, especially over the east. We also show an Atlantic overturning shutdown would be felt as far south as Antarctica. Rising warm air over the West Pacific would trigger wind changes that propagate south to Antarctica. This would deepen the atmospheric low-pressure system over the Amundsen Sea, which sits off the West Antarctica. This low-pressure system is known to influence ice sheet and ice shelf melt, as well as ocean circulation and sea ice extent as far west as the Ross Sea. A new world order? At no time in Earth's history, giant meteorites and supervolcanoes aside, has our climate system been jolted by changes in atmospheric gas composition like what we are imposing today by our unabated burning of fossil fuels. The oceans are the flywheel of Earth's climate, slowing the pace of change by absorbing heat and carbon in vast quantities. But there is payback with sea level rise, ice melt, and the significant slowdown of the Atlantic overturning circulation projected for this century. We now know this slowdown will not just affect the North Atlantic region, but as far away as Australia and Antarctica. We can prevent these changes from happening by growing a new low-carbon economy. Doing so will change for a second time in less than a century the course of Earth's climate history, this time for the better. This was from the conversation under Creative Commons here on Science Alert by Matthew England, Scientia Professor and Deputy Director of ARC, Australian Centre for Excellence in Antarctic Science, New UN South Wales, Sydney, Andrea Tacheto, Associate Professor, UNSW Sydney, and Brian Orihuela Pinto, PhD candidate, UNSW Sydney. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.